Hello, how are you all doing today? Today we're going to be looking at this question here. If you want to read it all, you can pause it. But basically, it's asking you to find the acceleration of the movable 20 kilogram pulley, which is pulling a 4 kilogram mass on a table with friction friction coefficient of a quarter and a 5 kilogram free hanging weight. Important things to remember is that the friction being a quarter and that the acceleration of the 20 kilogram movable pulley is going to be an average of the acceleration of the 4 kilogram mass and the 5 kilogram mass. Because although they're all in the same string with the same tension, the 4 kilogram mass is going to be moving at a different speed or accelerating at a different rate to the 5 kilogram mass. So I'm going to write out the forces for each of these. So the 4 kilogram mass has a weight, which is mass times gravity, which is 4 g's, and has a restorative force of the same because it's not moving up or down, which is the force that the table puts out on it, which is 4 g's. That's a friction force pulling it backwards. We know that the equation for friction is mu times r, the friction coefficient times r, so it's a quarter times 4, which is just g, and there is a tension pulling it towards the 20 kilogram mass, and the tension is the same throughout the entire rope, so the tension is the same throughout. And then the same equation for weight is in each of the masses, or in the 20 kilogram pulley. So mg 20 g's, and for the 5 it is 5 g's. So that's good. So then the 4 kilogram mass is accelerating towards the pulley at A, which you can't really see, sorry about that, and the 5 kilogram is accelerating with B, and the 20 kilogram is going down with A and B, or an average of both. So we're going to write out an equation to show to explain the movement of all of these. So for the 4 kilogram mass, we've got T, because it's moving in the same direction as the acceleration is positive, minus the friction because the sum of the forces. So the friction is going the opposite way to the acceleration, so it's minus the friction. So T minus G is equal to mass times acceleration over 4A. Then you can rewrite A as T minus G over 4. Then you do the same for the 5 kilogram mass. So we're going to have T minus 5G divided by 5. Or, sorry, when you write it, sorry. T minus 5G is equal to 5B. So B is equal to 5G divided by 5. So then you got A and B in terms of T and G. Okay, so then for the 20 kilogram mass, you've got 20 G's minus 2T. So 2T, because it's being pulled up on both sides, is equal to 20 times its acceleration of A plus B over 2. Now, just pause on that for a second. So it's A and B over 2 because its acceleration is an average of the accelerations of the other two. So you take the acceleration of the 4 and that of the 5 and take an average of those two to get the acceleration of the 20 kilogram mass. So then divide all that by 2 just to make it easier to deal with, and you've got 10G minus T is equal to 5A plus 5B. So then earlier on we wrote A and B in terms of T and G, so we're just going to rewrite all that in terms of the whole thing in terms of T and G, because then we only have one unknown, T, and so then we'll be able to write T in terms of G. So I'm sorry to go out of frame, but we see in a second you got 16.25 G is equal to 3, or 16.25 G is equal to 3.25 T, so 5 G is equal to T. So now the question asks us to find the acceleration of the 20 kilogram mass. So earlier on, as we said, the acceleration of the 20 kilogram mass is A plus B over 2. So we're going to write out that, and then we're going to rewrite it in terms of the A and B that we found earlier as well. So we've got half of A plus B, half of the value for A of T minus G over 4, and B, which is T minus 5G over 5, because you know the value for T, which is 5G. So we're just going to write that value for T, so then it's all in terms of G. So you've got a half of 4G over 4 and a half of 0G over 5 once you do the algebra, do the addition. So you got a half of G plus 0, which is just equal to G over 2 meters per second squared. Grand. Thank you so much for watching. It really does mean a lot, and I appreciate all criticism and comments. So if you've got any suggestions, just comment down below. I'll read it all. Thank you very much.